Welcome to Jade Platform Insights. I'm Jared Culling, and I'm going to be talking about logging in Jade. The first thing I'd like to address is why log? Why do we need to log? And I think it's actually one of the most useful development tools we have. It's the simplest, it's the oldest. It works in many situations when other more complex tools can't. And it's just fantastic. Today I'm going to consider two types of logging. The first type is what I would call development logging. This is logging that you do during the development of software. And the second type of logging is operational logging. And that's the logging that you would have running long-term in your production systems. So what's the first type of development logging? Debugging. This is the most useful use of logging, I think. In the dark mists of time before there were debuggers, the only real way for you to know how your software was running was debug output, printf or some other, ancient technology like that. And if you save that output to a file, you had a log. And really it's the most flexible way for you to figure out why something isn't working. And also, there are situations when you've got very complex software, which is multi-threaded and running in real time, a debugger just won't work because you stop one thread and all the other threads keep running, and now your code's a big mess and your state is all up the wazoo and you don't know where you're at. So there are lots of situations where logging is actually the only way to find out exactly what your program is doing. The next development use for logging is performance measurement. How long does this piece of code take? How often is it run? Are there any unexpected things going on that take way longer than you expect? Logging is a very low-cost way to quickly measure how long a small piece of code takes to execute. The other thing with logging over using profilers is that to fully instrument your code often changes how it executes because it runs slower. And also you might have a performance problem that only exists in a constrained environment where you can't run other more sophisticated tools. So again, logging gives you a way of measuring the performance of your software with a very low cost way. And this is kind of something I do a lot with complex code, because if you have any kind of a success in your software development, what you get is you get long-lived code bases that get increasingly complex. When you come along into an ancient piece of code and you're trying to figure out how it works, logging is a great way to see exactly how it works, because often when you look at the code and read it, it can give you the impression that it works one way, but then once you actually instrument it and log it, it doesn't quite work how you think it does. And the other thing is that if you've got code that's got high throughput of objects, sometimes it can be very difficult to see exactly how the code's performing. So I think this is another really good use of logging. Error conditions are kind of the bane of our lives. Often in code, you'll come along a statement which says, this value shouldn't be this now. How did we get here? And the question really is, what should you do? And often it's not obvious what you should do, but I think the minimum you should do is you should log this unexpected condition, and you should log as much context as you sensibly can, so that later when you're trying to figure out what happened, you've got some chance, I guess, of knowing what happened. The other thing, if you're in a highly regulated industry, you might have some legal requirements to log certain pieces of data, and so sure, fill your boots, do that. Also, there might be some what I would call high value critical decisions that your software is making. So it's good to collect statistics on things like that, so that your users can be assured that your software is operating in the way that you say that it is. If you're logging user interactions, you have to be careful to maintain privacy, and so the data needs to be anonymized so that you can't tell which user was using it, but you can log patterns of their behavior and you can find stuff out. But I would caution against too much logging in production systems. Logging doesn't come for free. Every time you log, you're going to the disk. That's an expensive operation. So you should really save your operational logging for very high value usage. So what tools does Jade provide for logging? The JadeLog class. JadeLog is a root schema class that's provided for logging. The primary method is JadeLog info. It takes a single string parameter, and that's going to be the content that is logged. And most of the other logging-based methods are really just variations on info. Log, which presumably actually came before log info in the history of JadeLog, is really just an info call plus a call to commit log. So, which means it seems like a big deal that you're going to flush the file, but actually it's kind of it isn't as big a deal as you'd imagine. The underlying operating system, they talk about having buffered writes, but it all manages to get onto the disk very quickly. So you would only really use log in a situation where you had almost a database-like need to know that your logging information had gone to disk. Trace is a conditional use of info. The dump variants are the way that you would log binary data. Now, when you're doing developmental logging, it's no problem to just whip up a local instance of JadeLog, because in a lot of your, if you're just figuring out why something isn't working, if you've got no time critical constraints on the execution of your code, you can just create a local instance of JadeLog, give it a file name, and then log the info. But for operational logging, we would highly discourage that kind of usage pattern. It's better off that you have a JadeLog class that is globally available, and the lifetime of the object has a sort of comparable lifetime to the application itself. And the main reason for this is that log files have a configurable maximum size, and by default, once that size is reached, we roll over, and if you've code hopefully is running a long time, and you may have lots of versions of the file. Now, each time the JadeLog class is instantiated, it needs to do an operating system call to the directory where you're doing all the logging to see how many of these instances. Now, it doesn't take it that long, but it essentially kind of make the time to log one piece of data sort of 10 or 20 times slower. That's why we would recommend having a long-lived version for operational logging. There are sort of two ways of setting the log file name. The first one is just there's the name and the path and the extension, and you can sort of set them up all separately, or you can just put a full path in the file name. Up to you how you want to do it. The only trouble is that if you do put a full path in the file name and then you query the file extension attribute of the class, it will still be null. There is a method called get actual file name if you really want to see what your file's called. Another thing to consider when naming files is how many applications will access this file. So if you have multiple copies of the same application running, and you have a piece of common code which sets up the name of your log file. Essentially what you've done now is you've got multiple threads all accessing the same log file, and this means that logging operations will take longer because they block on each other. The actual bit of code under the hood that writes the data to the file is single threaded. Essentially, it's lock protected. So if you are going to have multiple applications, better to add a process ID into the name of the log file, and there's a bit of sample code there on the right on how to do that. As I was talking about before, the JadeLog supports rollover. You get an instance number with your text, with your log name. When I was putting together this demo, I thought, I'm going to break it. I'm going to put a number at the end of my log name like an idiot. But no, it copes with that fine. I would not advise doing it because it makes the log numbering really weird. But essentially, you can set the max file size. 10 megabytes is a good place to start. That's a good, decent size. It's not too big. It's not too little. Once your log file reaches that size, it rolls over to the next one. And this just continues forever. So one of the things about operational logging to consider is log file archiving. Where is this stuff going? Why are you collecting this data? Is there any value in it? And if there isn't, stop doing it. How do we log information? Very simple. Call the info method on your logger class and stick some content in it. It doesn't need to be a string literal like in the example here. It can be any string variable. You can concatenate together bits of data in the way that you would build any string. We would always recommend using the info call. It's the fastest, it provides the best performance. There's no real downside to it. The ordering of log entries is guaranteed at time of calling. It gets a bit more murky, I suppose, if you've got multiple threads accessing the same file, but they should generally all end up in the same order that the calls were made. The only time you would really want to use log over info is if you had some dire need to know that the content of your log had been flushed to disk. There are, and obviously there's a small execution overhead to do with the flush, and I measured that at about 0.5 millisecond. So that gives you some idea about the differences. It's not great. What do you get in your log file? All log file entries are prefaced by a date, time, and a thread ID. You can turn this off by setting the format output attribute to false, and then you just get the content without any of the preamble. If you happen to set the selector attribute, then your selector will appear in the preamble. The selector is for use with the tracing statement. One thing to note is that once you've selected a selector, you get that selector in your preamble, regardless of whether you're calling trace, info, log, whatever, it just turns up. If you want to do selective logging, you can use the trace method. And so by using the selector attribute and having an entry in your ini file, you can control whether a trace call will actually do anything. So if you have it set up correctly and you make a trace call, then boof, you get your log entry. If your log file doesn't have the select entry, then no output to the log. We have a standard way of formatting binary data. So all the basic log methods have a dump variant. So info dump, log dump, trace dump, and they take the standard Jade binary data type, and they have space separated hexadecimal values in the log file. And then on the right hand side, if there are any printable characters, they get displayed in there. And finally, depending on the complexity of your application, you might have an application server and separate from your app. If your application makes a call into server execution, and you make a log call inside that server executed method, then the logging will happen on the database server node, which of course might not be on the same machine as your application. So if you want to force that logging in that method to be in the application node, then use the client variants of the logging. And likewise, if you were the other way around and you wanted to log, you're running it on the client, but you wanted to log on the server, then you would use the server variants of the logging methods. Right, now I'm going to do a quick demo. So now I'm going to demonstrate some of the basic features of logging by doing some logging. For the purposes of this demo, I'll be mainly running from the command line. This is a WSL window. That's so that I can run bash commands, and that's just because that's my preference and old habits die hard. So anything you see on this is a script that I use for starting my IDE, and here we have, up comes our Jade system, and I've got a one very simple user schema in here, and the schema has one application, which is a REST service, and I've designed this REST service so that when it starts, it creates a JadeLog transient called logger. We've got it set up so it'll do the format, the little preamble on each line of the log file, and set up the name to a local directory outside of the normal logging directory, just so that reduces the noise. And then this REST service has a number of endpoints, and each endpoint essentially exposes one of the JadeLog methods, so that I can control, which method will be implemented, and then we can see the effects of that. And so, that should become apparent. Now, as well as that, I have a bash script that I'm running everything from. So here's a bunch, you can see it there. Oh, that's exciting, yeah. But that's just to make it easy, because otherwise I've got, because I've got these complex commands that in the background are running those. I've got a REST client that will be making queries on those endpoints to make it all happen. So let's start. This will start that REST server, which is running in GUI mode, so that you can actually see there's something going on in the background. And if we have a look at our directory, there's nothing in it. And so now if we do an info command, which, if everything works, should stick the text info content into the first line of the log. So something happened. What have we got? Oh, look, we've got a log file. And now, using the standard Linux command for displaying contents of files, we can see that we have one entry in this file: date, time, the current thread, and some info. Even though we didn't explicitly flush the file by calling log, the info content ended up on disk almost instantaneously. And that's because that's the way the operating system works. So now if we were to run to log a entry, let's have a look at what's in there now. Now we've got two entries, one from the log, one from the info. But we've set this, the logger at the moment has got no selector, so that means that there shouldn't be any tracing going on. So if I do my trace call and then we see there's been no trace, inside any file ahead of time, I've set up a selector, my selector, sorry for the small text. But now if we set the selector, because I've got an endpoint for doing that. And now we try to trace something. And now we have a look at the file. Look, we've got a bit more content now. So that the conditional trace has worked because the selectors matches the contents of the ini file. And as I was saying before, if we log some more info now, we'll see that it's prefixed with the selector because the selector's on. And if we were to reset the selector, and log again, we should see that, yeah, the selector's gone. Now, if we dump some binary data, we should see, here we go, that's the format of the, it doesn't fit on the screen because I made the text so large. That's life. At least you can see it. That didn't take long, so let's do something a little bit more interesting. Let's see if we can log the time difference between the info and the log, so that you get some feel for what the actual execution constraints are. So if we bring back our system. Right, so what we're doing here is we're using the microsecond relative time that is available on the application system variable, and we're just getting the time before we call info. We're getting the time after we've called it, and then we're logging out. I suppose to be nice, we could say info of how long that operation took. And yeah, and let's do the same. Let's compile that. Oh yeah, all good. And then let's do something similar for the log method. What's an out? Okay. So now if we go demo info and have a look, we've still got our log file. Yeah, my log file. Oh. We'll see that it took us 1 millisecond to call info, which actually is kind of slow. Let's do it a few times, and then we have a look. Yeah, see, it's that's I guess a quirk of the file system. First one took quite a bit of time, but the rest of the infos, you can see they've only taken 200 or 300 microseconds to run. If we do the same thing with logging, and we have a look, we can see now that, yeah, the log operations do take longer. Again, this pattern of the first one takes way more, and then, it's 500 or 600 microseconds. So you can see there's sort of about a 500 microsecond or a half a millisecond difference between the call to log and the call to info. And also this gives you a bit of an example of how to do some pretty low-cost performance measurements of your code. Under the hood, it's using the high performance counter for getting those microsecond ticks. So let's set at the moment, I think the max size is set to 10 megabytes, like I was saying before, but let's make it very small. And then let's have a look at the disk. We've got one file. How large? We say one file has got a couple of K in it. Now let's go, if we go log and now have a look. Oh yes, we've got 2 because it's rolled over. And I have another command for logging a kilobyte at a time. And now we can see we've got 3. And if I go crazy, and what have we got now? Yeah, so you can see that the log files just build up over time. And that's the standard rollover. And, which is another thing that you need to be careful with, like I said before, with operational logging. You need to clean this stuff up. Jade won't do that for you. It doesn't know what you want to do with your logs. We wouldn't presume. So clean it up. Anyway, that's it. Hope you've enjoyed the demo. Thank you very much.